And now we're going to turn to sequential games in more details. So we've already looked at sequential games a little bit with the centipede game. But again, in sequential games, players make decisions one at a time. So player one goes first and then player two goes. Whereas in simultaneous games, they move at the same time. Okay. So there's going to be one move, then the other. So again, like chess or checkers, where player one goes first and then player two responds. All right. So when we have sequential games, the way that we represent them is with what's called a decision tree. It's also called the extensive form of a game. So that representation of the centipede game that you saw in a previous slide was a decision tree, right? It wasn't in the matrix. It was instead laid out with different branches that show the different paths that players could take. When it comes to sequential games, players are going to always use backward induction, right? Because they're going to know, okay, if I take this move, here is how my opponent will respond, and that is how they evaluate whether or not they actually want to take that move. So the centipede game, again, is an example. We saw how backward induction causes the game to unravel. Stackelberg competition, which again is just Cournot, but where one firm moves and then the other is another example. And then what's called the incumbent game is another example of a sequential game where we have a firm that's already existing in a market and is selecting their output in response to anticipated competition, right? So they're going to choose the amount of output that maximizes their payoff, which can either be make a lot so no firm can enter, or make enough so that when another firm enters, they don't earn losses. Okay, so let's look at that incumbent game. So, like I said, in the incumbent game, one firm is already present in a market, they're already operating. Um, and the other firm is choosing whether to enter the market or stay out. So, in response to a potential entrance choice, the incumbent can either choose to produce a large amount of output or a low amount. All right. And you can see here that the incumbent is the second player, right? So the entrant actually moves first, and they're going to make their choice based on how they anticipate the incumbent to act. All right. So the entrant, if they enter the market, they want the incumbent to produce a low amount of output so that they get good returns, while the incumbent wants the entrant to stay out of the market, right? And we can see this reflected in the payoffs. If the entrant enters and the incumbent produces a low amount of output, then they each earn 8 in payoff. If the entrant enters and the incumbent produces a lot, then the entrant makes a loss and the incumbent makes less than they would if they had produced a low amount of output. If the entrant stays out of the market and the incumbent produces a little bit of output, the entrant, of course, earns 0 because they're not in the market producing, while the incumbent earns 9. If the entrant stays out and the incumbent produces a lot of output, again, the entrant earns 0 because they're not operating in the market, and the incumbent earns 18, right? So they've doubled their payoff. All right. So based on these payoffs, the entrant is going to decide what ultimately they are going to do, right? Do they anticipate that if they enter, the incumbent will make low output or high output? And if they stay out, right, at that point, they don't really care what the incumbent does, right? But the incumbent will still be interested in what their choice will be. Okay. So let's go ahead and analyze this game. All right. So like we mentioned in the previous slide, we're going to use backwards induction. Okay. So for our entrant, they're going to move first. We're looking at their payoffs, right? So if they stay out, they earn nothing, right? If they enter and the incumbent produces a low amount of output, they earn 8. And if the incumbent produces a high amount of output, they earn -3. All right. So when they're considering these two, their preference is, of course, that they enter and that the incumbent produces just a little bit of output. The question is if that will actually happen. Okay. So if we look at the incumbents' incentives here, their payoffs, if the entrant stays out, then that incumbent wants to make a high amount of output because their payoff is 18 rather than 9. If the entrant enters, then the incumbent is going to prefer that they produce a low amount of output because here they earn 8 rather than 6. All right, so the entrant is going to know that. And so knowing that if they enter, the incumbent chooses low output, right, then the entrant can confidently select that enter choice, knowing the incumbent chooses the low output and our equilibrium is 8, 8. Okay. Um, that is going to end our treatment of sequential games. Um, and now we're going to turn to thinking about how players can increase the likelihood that their opponents will cooperate with them.